there will soon be a new moon on Earth. Alien celestial body is about to be briefly become a partner of our blue home planet by its gravitational pull. But this naturally occurring satellite is a little smaller than our famous moon. In only 2 months, the 10-meter diameter asteroid 2024 PT5 will escape Earth's gravitational pull and vanish into the emptiness of space. It is a unique type of moonwalk that was just spotted on August 7 of this year by the Asteroid Terrestrial Impact Alert System telescope located in South Africa. On September 29, the asteroid 2024 PT5 will depart its horseshoe-shaped orbit and experience Earth's gravity up close. More specifically, the cosmic lump will undergo a so-called momentarily captured flyby, turning into an Earth mini-moon for roughly 2 months, or 56.6 days. However, in specifics, this thrilling occurrence is not a new astronomical phenomenon. In actuality, tiny asteroids frequently acquire new partners after becoming ensnared in our home planet's unseen grasp. But we've just been aware of this for the past 12 years or so. When astronomers from Arizona's Catalina Sky Survey discovered a small car-sized object in Earth's orbit in September 2006, they weren't sure if it was a piece of space junk or a naturally occurring lump of rock. The sole certainty was that the object had departed Earth's orbit in June 2007 and was moving in the direction of the Sun. Astronomers debated if the incident was a one-off or if our planet might frequently pick up tiny asteroids and temporarily make them a companion. After researchers at the University of Helsinki utilized a supercomputer to analyze the trajectories of 10 million near-Earth asteroids, the debate was finally resolved in the spring of 2012. It was evident that there is almost always a mini-satellite in Earth's orbit that has a diameter of at least 1 meter. Additionally, some mini-moons stay in Earth's orbit for decades, even though they typically orbit the planet 2.9 times before departing again after roughly 9 months. However, isn't there a risk associated with this encounter with the captive asteroids? Put differently, is it not possible that this constellation may result in impacts? The experts say that this situation only threatens us in the most extreme circumstances. After all, it is estimated that only 0.1% of the boulders that have collided with the Earth's surface thus far were once mini-moons. How will PT5 become the Earth's new moon in 2024? An Arjuna asteroid is the classification for the impending mini-moon visit. The low inclination, low eccentricity, and roughly 1-year orbital period of this class of near-Earth asteroids are characteristics that make them resemble Earth. The matching celestial bodies frequently turn into Trojans because they orbit the Sun at the height of the Earth's orbit. In astronomy, this term refers to asteroids that come before or after a planet in its orbit, although it usually conjures images of wooden horses and legendary conflicts. There are 2 Trojans known to exist on Earth, but most of our partners travel in a horseshoe-shaped orbit that occasionally gets them within a few million kilometers of us. This distance is quite small by astronomical standards, and it is also anticipated in the case of PT5 in 2024. It will pass just beyond the Hill sphere between September 29 and November 25 making it roughly 1.5 million kilometers from Earth. As a result, it will come under the gravitational pull of our home planet. To put it succinctly, the Hill sphere in astronomy refers to the environment of a body when its gravitational pull is stronger than that of a more massive body it circles. Unfortunately, those who were hoping to witness the wonder of 2 moons in the night sky in the upcoming weeks will be let down. Even though PT5 is one of the largest mini-moons, measuring 10 m across, it is still too small and too far away for Earthlings to view with the naked eye. Actually, even with smaller telescopes, it is probably going to stay undetected. However, at least it will come see us again later. The asteroid will first stay in our near area before returning to a heliocentric orbit around the end of November. It will once more come within 0.12 astronomical units, or 1.7 million kilometers, of Earth on January 9, 2025. However, the lunar on-off relationship is then temporarily suspended throughout the ensuing period. The cosmic mass will eventually depart from Earth's orbit and return to our planet only in 2055. The experts are faced with a great conundrum because of this odd mini-moon. Even with all of the brief visits, 2024 PT5 might still be able to assist us unravel a new space mystery. However, our planetary neighbor Mars is the subject of this interplanetary enigma, not Earth. Phobos and Deimos, the two moons that orbit the red planet, are undoubtedly unique in appearance. Given their strange appearance, many researchers believe that Phobos and Deimos were previously asteroids that sailed across space before being drawn into a permanent orbit by Mars's gravity. However, there are other explanations for these unique Martian partners besides this one. It is also possible that we are dealing with a concentrated field of debris in the case of Phobos. It's possible that an asteroid once struck Mars' surface, sending some of the crustal material hurtling into orbit and building up into a new body of space. According to another view, Phobos and Deimos are actually the remnants of an older, bigger Martian moon that split apart over 2.7 billion years ago. However, despite this fascinating enigma, we must remember that we still have a lot of questions about our own moon, and that we are still unable to determine its exact formation. A collision is also suggested by one idea. This suggests that in the early solar system, a celestial body the size of Mars might have collided with the infant Earth, causing material to be thrown up in the process, which eventually condensed to form the moon. Although we would have provided the moon with some of its material supply in this scenario, the opposite might also be true. Our steady companion has returned the favor by giving us a mini-moon, according to an intriguing theory. This specifically refers to the asteroid Camo Alua, which orbits our home planet as a mini-moon and is roughly 5 times larger than 2024 PT5 at 50 m. In specialized circles, these co-orbital companions are also referred to as quasi-satellites, although Camo Alua's origin has long baffled astronomers. After being expelled from the asteroid belt by collisions or gravitational turbulence, the majority of mini-moons were subsequently drawn into the Earth's gravitational pull. The course of this one, however, oddly deviates from the typical mini-moon pattern. It appears that the celestial body alternates between a horseshoe-shaped orbit and a circular one around the Earth. And even though mini-moons aren't often known to stay close to Earth for extended periods of time, this object has been doing so for a remarkably long time. According to specialists, it will take at least another 300 years for Camo Alua to return to the horseshoe orbit, having maintained its current position as a quasi-satellite for nearly a century. Additionally, the orbital changes may last for hundreds of thousands or perhaps millions of years. However, why is this odd behavior occurring? Well, the makeup of the heavenly body may hold the solution to this query. This is very different from that of ordinary near-Earth asteroids, and more like the regolith that is abundant on the moon's surface. As early as 2021, there were speculations that Camo Alua might actually be a lunar rock that had previously been pushed out of our satellite by an impact. At first glance, the explanation for how the moon gave Earth a mini-moon seems very feasible, but there is a major caveat. For a long time, experts thought that such a scenario was very unlikely, if not impossible. Because a moon fragment actually has too much kinetic energy to swing into an Earth orbit as a mini-moon if it has enough to escape the moon's gravity. A research team from the University of Arizona had virtual fragments sent into space by strikes on the lunar surface in every possible location, angle, and speed in order to test this thesis once more. As a result, very few of the fragments that were launched actually reached low Earth orbit. However, exceptions prove the rule, as is frequently the case. Ultimately, 6.6% of all collision pieces have succeeded in momentarily entering a co-orbital motion. The majority of these, 5.7%, were later discovered to be on horseshoe orbits, but 0.8% explained a combination of horseshoe and quasi-satellite trajectories. Additionally, there are a few things that make it more likely for a piece of the moon to enter an orbit around the Earth. The most promising mini-moon candidates are those fragments that, when ejected, are just marginally faster than the required escape velocity of 2.4 km/s. Additionally, several of the simulated objects exhibited orbital dynamics that were just as stable as Camo Alua's, even though the majority of them were only in close proximity to Earth for brief periods of time. Without a doubt, such a case is quite uncommon, but the research findings indicate that it is conceivable that the origin of the mini-moon Camo Alua may be right in front of us. In fact, the source of your subscription is directly beneath our video. Please feel free to subscribe and give us a thumbs up so you don't miss any more of our entertaining videos. See you shortly.